Keys to Algebra. These are some word problems from books 3 and 4. They're not in any particular order, and it's kind of hard to define them because all I can give you is a book number and a page number, and then this is the name that I gave to the problem. The first one is about a rectangle area, and we're given a rectangle that looks like this. This is in the polynomial book. Okay, so we're supposed to solve for x. Okay, well, what do we know about rectangles? We know that the area of a rectangle equals the length times the width. And as we look at this picture, we realize we have all that information. The area equals 210. The length, which we normally consider the long side, but it doesn't really matter. But let's call that the length, 2x plus 1, and the width equals x. So I'm going to take this information and I'm going to plug it into that formula. Here's my puffy cloud of knowledge. This is all the information I'm using to attack this. And so I get 210 equals, I'll put parentheses around this binomial, 2x plus 1 times x. Oh, okay, I feel good about that. Let's distribute. 210 equals 2x squared plus x. And now let's kick the 210, let's swim the 210 across, so that'll become negative 210, but let's write this first and then the equal sign. All right, so I'm just gonna switch sides on this. So I'm gonna write 2x squared plus x, that's this side, then bring the 210 over and let that equal 0. That was a little confusing just because I want my trinomial on the left. That's how I'm used to it, and I was accumulating it on the right. So I just picked it up and dragged it over, made them change sides. All right, now I'm ready for some fancy advanced factoring. By the way, if advanced factoring gives you hives, just use the man-eating dragon. Just use the quadratic formula. You can do that, or even complete by the square if you like that. You don't have to use advanced factoring. It's considered easier, but if it doesn't feel easy to you, move on, do what you want. I'm gonna solve this by advanced factoring though, just to give you that option. Remember that we want to find two numbers that multiply to a times c, right? Which in this case is minus 420. And then they have to add to b, which is 1. Wow, that's weird, right? Such a big number, but the factors are only gonna be 1 apart. And I'm just gonna put a positive there to help me remember. So I don't think I can generate a lot of factors to 420 just off the top of my head. So what you can always do, don't worry about the minus sign just yet. Find the prime factors of this. I'm gonna do 42 times 10. This quickly breaks down to 2 times 5, those are prime. 42, let's see, that's 6 times 7. 7 is prime, and then 2 times 3. Okay, so there are the prime factors of 420. 2 times 2 times 3 times 5 times 7. And so now what we do is play around with these, accumulating them in different patterns and trying to find one whose difference is just 1. Okay, so you just start playing, right? So let's do the first 3. That would be 4 times 3 is 12 and 35. Well, I can put the minus on either one of those, and I'm not going to get a difference of positive 1, am I? Okay, so I keep playing. What about, let's do the 2 and the 7, and then those guys in the middle. That would be 14 and 30. No, not getting warmer. I know I could do 20. Oh, look, 2 times 2 times 5 gives me 20. 3 times 7 gives me 21. There it is, right? And I'm gonna need it to be plus 21 and minus 20 because I want my difference to be positive 1. Okay, so I had to play around for a while, but I found it. right? The prime factors, getting a list will help you play with the numbers. Okay, so I'm gonna bring this up here. I'm gonna split this. I'll just do them in this order. I'll do minus 20x plus 21x. And I just stop to double check. Yes, that equals 420. And when I add it, I get positive. Okay, so this has become this, and these two stay the same. 2x squared minus 210 equals 0. Sometimes we do these just as expressions without the equal sign. Sometimes we do them with. Make sure you keep track of which one you're doing. This one we're going to be able to solve all the way down to x. Okay, now I'm ready to factor by grouping. It's really fun, you guys, because we've been working a lot on this factoring by grouping, and Caleb and Jackson are learning it for the first time in their Algebra 1 lessons, so it's really fun. Okay, for this I can pull out, let's see, a 2x, right? And that will give me x minus 10. And then I'm going to pull from here, let's see, I can take out a 21. And that will give me x minus 10. Beautiful. Okay, I rewrite the pieces. This is the art project part. And now I have to evaluate both of these for x and see what happens. Okay, so this one, if I take 2x plus 21, remember this is, we call this the zero product or the zero factor theorem. It goes by both names. And it's saying if you multiply two things together and get 0, then one or the other of these has to be 0, right? That's the only way to get 0 as a product, is one of the factors has to be 0. So either 2x plus 21 equals 0 or x minus 10 equals 0. All right, this will become x equals minus 21 over 2. Is there any possible way that the length of this side could be minus 21 over 2? No. It's illogical. So we can, because it's negative, so we can just rule that out. This one is x equals 10. Oh, okay, that sounds like a good answer. Now, we can check the answer. And this is a great tool. I don't like to do it in homework because, but it's a great thing to do when you're taking a test because you can be sure your answer is right. So if our answer is right, then 10 times 2 times 10 plus 1 should equal 210, right? That's our original, it's our original equation, right? If x is equal to 10, then 10 times 2 times 10 plus 1, right? That's what I've written here in a slightly different order. This should be true. Let's check. We'll do the work in the parentheses first. That'll be 20 plus 1, that's 21. 10 times 21 equals 210. So we know that this is the right answer because we checked it. And I don't have the problem in front of me. It's hiding in my phone while I film this, but I think they just ask for the value of x. If they wanted to know the two sides, we figured that out already. The other side, we could say that the length equals 21 and the width equals 10. If the problem were asking for that. That's the algebraic answer that's important. Okay, beautiful. Moving on. Problem 2. Based on our list, this is the problem about the Shake Shack. And this is the trick problem. Let's see, it's book 3, page 25. This one is a trick. It tells us how many it says we bought. I don't even remember the numbers, but I will tell you this, it's unsolvable. We don't have enough information to solve that problem as the way it's written. All right, so that is a trick. 3, that is our phone call. That is book 3, page 25 also. And we're told that it's 80 cents for the first 3 minutes. You guys don't even know about long distance. It's so fun that just was never a part of your life. And then it's 20 cents for each additional minute. Okay, and we've got $3 to spend. But we want to rewrite that as 300 cents, right? We're talking about cents here, so we don't want to mix dollars and cents. And I sure don't want to write everything as a dollar because then I'll have a bunch of decimals and I don't want to deal with that. Okay. So what we want to do, we know we've got enough to pay for the first 3 minutes. So that's not even a thing. We know we're going to spend 80 cents and then we're going to spend 20 cents per minute times some certain number of additional minutes up to 300 cents, all right? So our X is gonna tell us how many additional minutes we can afford. We know for sure that we can afford the first 3 minutes, okay? The question is how many additional minutes can we afford? So we'll do the math on this, the algebra. 20x equals 220. We divide it by 20 to isolate the x, and we find out that x equals 11 minutes. But that's the additional minutes. So we take the 11 additional minutes plus the 3 original. And that means that for $3 we can afford 14 minutes. In our phone call. Does that make sense? We were solving to find how many additional minutes we could have. We know that we paid for the first 3 in that. All right, beautiful. That's problem 3. And then we have one more, the age problem of Ellen and Maja. They're 2 friends. This is book 3, problem, page 27. Okay. This one is easier than a lot of the ones we did with John at the end of Algebra 2. There's an age word problem. I think we reviewed these in advanced mathematics, but that was way back at the beginning. The trick to these is to set up a chart in the beginning so that you can create these variables. I like to keep these in chronological order. So we're talking about last year and now. So I'm going to put them in that order. Their ages last year, their ages now. We have Ellen and we have Maja. Okay, so their now ages, I'm just going to say E and M. And then last year, it will be -1, right? That's how we can write a variable about last year. So the first thing we know is that this year, Ellen is 11 years older than Maja. So I start with an inequality. Ellen is greater than Maja, and I know she's 11 years older. So I add that to Maja's age. You know, I always like to adjust on this side. We could have done E minus 11. We have to do something that will make this side smaller or this side bigger in order to bring that inequality into a balance. Okay, so we have our choices on how to do it. Again, we could make this one smaller or this one bigger. Either one of those will correct that imbalance in the inequality. Okay, last year, we know that Ellen was twice as old as Maja. So again, I'm going to write an inequality. Last year, Ellen was also older than Maja. She was twice as much older. So we'll multiply Maja's age last year by 2, and then they'll be equal. Okay, so I have 2 nice equations here that I can substitute in. I'm going to do that. I'm going to take this E and I'm going to put it in right here. Okay, so I'm going, if I call this one A and this one B, I'm going to substitute A into B. So then I'll have, that's where the E goes, and it'll be M plus 11. That's the minus 1 equals 2 times M minus 1. Got it? Okay, now we just do some fun solving. I don't need these parentheses, and I can combine like terms here. So M plus 10 equals 2M minus 2. All right, let's swim the M's this way. And then we'll add 2 to get the plain numbers over on the left. That cancels, that cancels. 12 equals M. So Maja's age now is 12. That's the answer that our problem was looking for. Peter and Julie were looking for that. But let's go ahead and figure out all the ages and make sure that it works. Again, we can check our answer even if we don't have it. Okay, we know that Ellen, I was going to say Aaron now is Maja's age plus 11. So that means she would be 23. Okay. Now, if we did this right, we can subtract 1 to find their age last year, and Ellen should be twice as old as Maja. Let's try it. Okay, 23 now. That means subtract 1, she's 22. Maja was 11, and look, there it is. Ellen is indeed twice as old. So these ages check out. This checks out. That's our answer, and we can feel pretty darn certain that it's right. Okay, so I do recommend that to you. The AccuPlacer is not timed, so you can take as much time as you like to work through these answers, to check them, to make sure that what you figured out is logical and fits when you go back and plug it in. We were able to do that for this one very easily. We were able to check it here, right? This was where I checked up here. Whoops. Right, I did it in my table. That's where I checked it there. The one about the Shake Shack, we can't really check. And let's try checking this one, because we didn't do that before. This is the phone call problem. Okay, so if they say 14 minutes, it would cost us 80 cents for 3 minutes, right? That's the first one. And then we said 11 additional minutes. So that would be 11 times 20 equals I'm mixing up my times and my dollars. I've got my columns mixed up. Okay, so it cost us 80 cents for the first 3 minutes. And then we're saying let's do 11 minutes more at 20 cents. Let me write that on this side. 11 minutes more times 20 cents each. That would be 220 cents, right? 11 times 20. We add this up, and that's 300 cents. And that's how much we said that we had to spend, $3, right? So there's the check on that one too, and this works. All right, so think about that as you go. There's always a way to check your answer. We can't check the Shake Shack, but I'm pretty sure that one's right. Okay, 1, 2, 3, 4, we're done. Yay, bye.